Assalamualaikum and good day everyone. So today we are going to continue with the last subtopic of lecture 2, which is the definite integrals. So the learning outcome of this lesson, at the end of the lesson, students should be able to use the properties of definite integrals. Okay, so previously we all have done integration without any values. So for this one, we are going to use some values or representation of values to find the definite integrals. So some general properties of the definite integral. So the first one, if we have integration of a function c respect to dx from a to b, then it will be equal to c multiplied by b minus x. So actually, if we do the indefinite integral without the value of a and b, we will get cx plus c, right? Constant c. Okay, so what we need to do is to substitute the value of x for the upper limit, subtract with the lower limit. So what we have done is c multiplied by b minus c multiplied by a. That's why we have factorized out c of b minus a. So these two c are different c. So let's say if you use constant k, I would like to use constant k. So integrate k respect to x from a to b. It is like integrating k, though we get k multiplied by x, and then it's come from a to b. So what we need to do to substitute the value of x from b, and then minus k multiplied by a. So that's why we can factorize out the constant k and then b minus a. Okay, this is the longer way lah. So directly you can use the properties, which is just substitute b minus a into the function. Okay, so a is the lower limit, b is the upper limit. So integration of fx plus or minus gx means that addition or subtraction between two functions from a to b, we can separate into, we can find the definite integral separately. Okay. The third one, integration of c multiplied by a function, a constant multiplied by a function. So this constant is just a coefficient, so we can factorize out. And then for integration of fx from a to c, we can find it by separate into two interval, means that we can find the integration of fx from a to b and then adding up from b to c. So continue from a to b, b to c, where b must be in between a and c. And then the last one is integration of fx from a to a. So means that it's starting from one point to that point. So it didn't move anywhere. So it is equal to 0. And then integration of fx from a to b, it is equal to negative of integration of fx from b to a. So we have the opposite sign if the limit change. So the lower limit be the upper limit. So let's see some example. Example 1, integrate, given that the integration of fx from 2 to 7 is equal to 5. Find the integration of 3 of fx from 2 to 7. So applying the properties of definite integral, we can factorize out the 3 as the coefficient. So it will be 3 multiplied by integration of fx respect to x from 2 to 7. So what is the integration of fx respect to x from 2 to 7? We know it is equal to 5. So it's equivalent to 3 multiplied by 5, which is equal to 50. So for question B, integration of x minus 2 of fx respect to x from 2 to 7. So we can apply the addition or subtraction between two functions. So it will be integration of x respect to x from 2 to 7 minus with integration of 2 fx respect to x from 2 to 7. And then this 2 is just the coefficient we can take out. And then integrate x, so we get x squared over 2, and then substitute the value 2 and 7. So when you subtract 7, you have to when you substitute 7, and then you will subtract with when you substitute x equal to 2. And then the right side, we know the integration of f with respect to x from 2 to 7 is equal to 5. So 2 multiplied by 5. So what do we get as the answer? So substitute 7 into the x. So we have 7 squared, which is equal to 49 over 2. Minus with 2 squared, which is 4 over 2. So we get 45 over 2 minus 10. So the answer will be 45 over 2 minus 10. 10 is equal to 20 over 2. So 25 over 2. So example 2. Given the function fx from 1 to 3, the integration of function fx from 1 to 3 is equal to 5. And the integration of fx from 3 to 8 is equal to 10. Now, evaluate the integration of fx from 3 to 3. So, we didn't move anywhere, so it is equivalent to 0. Just directly use the properties. And then, integration of fx from 3 to 1. So, we don't have 3 to 1, we only have 1 to 3. So, notice that the limit exchange. So, it is equivalent to negative of 5. Okay? And then, for question C, integration of 4 times of fx respect to x from 1 to 3. So from 1 to 3, so we have coefficient of 4, so we can factorize the 4 multiplied by the integration of fx from 1 to 3, which is equal to 5. So 4 multiplied by 5 equal to 20. For question D, integration of fx from 1 to 8. So we don't have 1 to 8, but we have 1 to 3 and 3 to 8. So we can just adding up. Okay, so integration of fx with respect to x from 1 to 3, adding up with integration of fx from respect to x from 3 to 8, we get 5 plus with 10. So the answer will be 15. Okay, so example 3, evaluate the integration of x cubed plus 1 respect to x from negative 1 to 3. So how do we solve the definite integral? First of all, what you need to do is to integrate as usual, but without plus c, without the plus the constant. What you need to do is to put the square bracket and put the upper and lower limits. So integrate x cubed. What do we get? It's equivalent to x power 4 over 4. And then integrate 1, we get x. And then put the lower and upper limit. So lower limit is negative 1, upper limit is 3. And then after that, you can just substitute the value of x for the upper limit first, which is 3 to the power of 4. 3 to the power of 4 over 4 plus 3. So we just replace the x. And then subtract with when you substitute the x equal to negative 1. So negative 1 to the power of 4 over 4 plus negative 1. So this is the next step, the most basic step. Okay? And then after that, you use the calculator to calculate. So we have 81 over 4 plus 3 minus with in the bracket of 1 over 4 minus 1. So this is equivalent to negative 3 over 4. This is equivalent to 12 plus 18 is equal to 93 over 4. So 93 over 4 minus negative 3 over 4. So 96 over 4, which is equal to 24. Okay? So this is how we find the definite integral. What you need to do is just substitute the upper limit and then subtract with 1 when you substitute the lower limit. So let me write down this again. So the step should be substitute the upper limit and then substitute the lower limit and then subtract it. Okay, so you can just directly substitute into the you can just directly calculate using your calculator and then directly you get the answer. Okay, so for question B, integrate the 5 over x respect to x from 1 to e. Okay, so this is in a form of fraction where the x is in the denominator, and this 5 can be the coefficient of 1 over x. So we can factorize out 5. So what we want to integrate is 1 over x respect to x. So integrate 1 over x, what do we get? This 5 will be outside of the square bracket. So integrate 1 over 5, we get natural log of x. So we have the limit which is equal to 1 to e. And then substitute the upper limit and then subtract with the lower limit. So it's 5 multiplied by natural log of e minus natural log of 1. So natural log of 1 is equal to 0. Natural log of e is equal to 1. So 5 multiplied by 1 is equal to 5. Okay? Just substitute the value. Example 4. Evaluate the integration of e to the power of x plus 1 respect to x from 0 to 2. So, we know that integrate the e to the power of x plus 1, this is a linear. So, ax plus b. So, it should be dividing by the a. So, what is our a? Our a here is 1. So, that's why directly we get the answer of e to the power of x plus 1. Okay, so you need to apply the rule of integration. So put the limit, so 0 to 2, substitute the value, we get e to the power of 2 plus 1 minus e to the power of 0 plus 1. So this is equal to 3, this is equal to 1. So e to the power of 3 minus e, which is equal to, you can directly calculate using your calculator or you can leave it as e. This is a constant. So example 5. Evaluate integration of x over 1 plus 4x squared respect to x from 1 to 2. Okay, so how do we integrate? So we don't have any quotient rule or anything, but this is in the form of fraction. So we can either apply the formula of f prime x over fx, the integration of f prime x over fx, or you can apply substitution method. So either one. So if you want to apply the first special formula, what we need to do is to check what is our fx. So if you want to use substitution, we need to determine what is our u. So here we can use the substitution method where we take the denominator as u. So u equal to 1 plus 4x squared. So it's supposed to be that du dx equal to 8x. So du is equal to 8x dx. We separate the variable u and x. But in the question, we don't have 8x dx. We only have x dx. So this 8, we bring it to the left side. So du over 8 is equal to x dx. Now, what we need to do is to just replace everything with respect to u. So the denominator will be u and x dx will be du over 8. So the answer should be what? The integration of 1 over u. Okay, so before we continue, this limit is for x, right? Respect to x. So if we change by using substitution, we change into u, means that the limit also need to change into u. So what is u when x equal to 2? What is u when x equal to 1? So substitute into the function u equal to 1 plus 4x squared. So when x equal to 2, u equal to 1 plus 4 multiplied by 2 squared. So 2 squared is 4, 4 multiplied by 4 is 16, plus 1 is 17. And then when x equal to 1, u is equal to 5. Then 4 multiplied by 1 squared is 4, 4 plus 1 is 5. So the limit will be 17 and 5. So the lower limit is 5, upper limit is 17 of, what is x dx? What is 1 plus 4x squared? 1 plus 4x squared can be changed into u. So 1 over u. And then multiply by du over 8. Okay, if I'm doing this, I will write down 5 to 17 of 1 over u multiplied by, sorry, 1 over u multiplied by du over 8. So 1 over 8 will be the coefficient. We take out it from the function. So what we want to integrate is only 1 over u respect to u. So what do we get? 1 over u. 1 over u, integrate 1 over u is natural log of u. So from 5 to 17, you can just directly substitute because this 17 and 5 is in term of u. So it will be 1 over 8 of natural log of 17 minus natural log of 5. So this can be the final answer because ln 17, natural log of 17 is a constant. Natural log of 5 also is a constant. Everything here is a constant. Or you can calculate using your calculator and give the answer following the instruction in the exam paper. It's either 3 significant figures or 3 decimal points. It's up to the instruction lah. So please check the instruction first. So here if we give the answer in 3 decimal places, it will be 0.153. So example 6, evaluate the integration of 3x squared multiplied by square root of x cubed plus 1 respect to x from -1 to 1. Okay, so how do we settle this question? So we have a square root here, means that it's the power of 1 over 2. So if we have an expression with a power, then we can use the formula. Special formula f prime x multiplied by fx to power of n. Or we can also use substitution, let u. So choose whichever you want if they didn't state what method you want to use. Okay, so let u. So if you want to use substitution, so we let u of everything inside the bracket lah. So because we have the index, right? So we take this one as the u. So u is equal to x cubed plus 1. So suppose differentiate u respect to x, we get 3x squared. So du equal to 3x squared dx. And then because the question obviously has 3x squared dx, so we don't have to change anything. So we just directly replace 3x squared dx with du. So the answer will be what? So we can change this expression in x into u by letting u equal to x cubed plus 1. So u to power of 1 over 2. Okay, so I forgot again. So we need to find the new limits. So what is the new limit? So when x equal to 1, u equal to 1 cubed plus 1, which is equal to 2. And when x equal to -1, u is equal to -1 cubed, which is -1 plus 1 is 0. Okay, so it's from 0 to 2 of u to power of 1 over 2 du. Right? So this is u to power of, we have square root there. So it's to power of 1 over 2. And then 3x squared dx is equal to du. So now, what we need to do is just integrate u to power of 1 over 2 respect to u. Simple, right? So, integrate, we get u cubed, u to power of 3 over 2 divided by 3 over 2 from 0 to 2. And then substitute the value of u with 2 and 0, subtract it. So we get 2 to power of 3 over 2. Also, we can take out this constant because it depends on the value of limit. So take out it, we will get 2 over 3 of u to power of 3 over 2 from 0 to 2. And then substitute the value u, you get 2 to power of 3 over 2 minus 0 to power of 3 over 2, which is equal to 0. So what is 2 to power of 3 over 2? So it will be 2 to power of 3 equal to 8. So square root of 8 is equal to square root of 4 multiplied by 2, which is equal to 2 third 2. Okay, so if we do the change in the form of using the rule of indices, or directly you use your calculator. If you use this form, what you get is 2 over 3 multiplied by 2 third 2, which is equal to 4 over 3 third 2. Right? Okay. So example 7. Integrate e to the power of natural log of x plus 1 all square respect to x from 0 to 1. So actually what we need to do, the first thing is that, see, we have a base of e and power of natural log to base of e. So we can use the properties of logarithm to solve this type of question. So what is this equal to? This is like x to the power of log base x of a, which is equal to a, or usually we use this one, base a to power of log to the base a of x is equal to x. So this is actually equal to x plus 1 to power of 2 respect to x from 0 to 1. Okay, so you can use the general power rule because it's a linear. Here it's x plus b. You can use the general power rule, or you can expand. So if you want to expand, it will be x plus 1 multiplied by x plus 1. So it will be x squared plus 2x plus 1. So you can use either one. Both are correct. Okay, so for this one, they want to use substitution. So this is also correct. Okay, why? Because when we differentiate u, we get, with respect to x, we get 1. So directly du is equal to dx. Right, du dx is equal to 1. So du is equal to dx. So we have dx can be replaced by du, and then x plus 1 all square can be replaced by u square. So we need to find the change of limit. So when x equal to 1, what is u? So u equal to 1 plus 1, which is equal to 2. When x equal to 0, u equal to 1. So we have the new limits when it is u. So what we need to do is to replace x plus 1 by u. So u squared multiplied by du, because dx is equivalent to du. So integrate u squared, we get u to the power of 3 over 3 from 1 to 2. So substitute the value, we get 2 cubed over 3 minus 1 over 3. So we can factorize 1 over 3. So we get 2 cubed minus 1, which is equal to 8 minus 1. So it's 7 over 3. Okay. So if we want to use the general power rule, we will get ax plus b to the power of n plus 1 over n plus 1, right? So it will be x plus 1 to the power of 3 over 3 directly from 0 to 1. So if we substitute the value, we can factorize out 3. So it will be x plus 1 to the power of 3 from 0 to 1. So it will be 1 over 3 of 1 plus 1 cube minus 0 plus 1 cube. So this is 2 cube, which is equal to 8. This is equal to 1 cube, which is equal to 1. So 8 minus 1 is equal to 7. So 7 over 3. It's still true. How about if you use expansion? Okay, so let us use expansion. So what we want to integrate is x squared plus 2x plus 1 respect to x from 0 to 1. So we get x cubed over 3 plus x squared plus x from 0 to 1. So we get, if we substitute 1, we get 1 over 3 plus 1 plus 1 minus 0 plus 0 plus 0, right? So this is 1 plus 1 is 2. 2 over 3, 2. If we change into fraction, it will give 6 over 3. So 6 plus 1 is 7 over 3. It's still the same. Okay? Okay, so there are several methods you can solve for this type of question. Example 8. Okay. Now, read the question carefully. Evaluate integration of 3x e to the power of negative x squared from 0 to 1 by using substitution. So, they ask you directly to use substitution method. Okay, so you cannot use other methods. So, if it's substitution method means that you have to let u find what is your u. So for this type of question, it's an exponent, right? So directly the index will be the u. So let u equal to negative x squared or x squared. Doesn't matter with the sign. Okay, if we take x squared, what do we get? We get du dx equal to 2x. So du equal to 2x dx. Do we have 2x dx in the question? No, we only have 3x or x dx. So the 2 will be, bring it to the left side. So we have du over 2 equal to x dx. Okay, so we can replace the x squared and the x dx. But before that, we need to find the new limits. So when x equal to 1, then what is u? Okay, so we take out the 3 here because it's just a constant. So if x equal to 1, u is equal to 1 squared, which is equal to 1. And then when x equal to 0, u also equal to 0 because it's 0 squared. So the limit is still the same from 0 to 1. So what we need to do is to replace the power, the index. So we get e to the power of negative u, and the x dx here will be du over 2. Okay? So the du over 2, we can take out the 2 as a constant. So 3 over 2 of integration e to the power of negative u from 0 to 1. So integrate e to the power of negative u, we know it's equal to e to the power of negative u and the coefficient of u, which is negative 1. So that's why we have negative e to the power of negative u from 0 to 1. And then we need to substitute the value lah. So it's negative. We can take out the negative outside. So negative 3 over 2 of e to the power of negative 1 minus e to the power of negative 0, which is negative 0 lah. So e to the power of 0 is 1. So we have negative 3 over 2 multiplied by 1 over e minus 1. So this is our final answer. Or also you can just use your calculator to find out the answer in a decimal point, which is equal to, try to use your calculator. Do you get the answer or not? This e is e to the power of 1. So you can either use the alpha e to the power of 1 or shift e to the power of 1 or alpha e. Okay, so that's all for this example. Lastly, example 9. The function f is defined as this is a piecewise function. So from negative 1 to 2, we have a different function, which is function 3x plus 4. But from 2 and above, we use 1 over 2x squared. So now the function, the question is asked to determine the integration of fx respect to x from negative 1 to 3. So negative 1 to 3. Negative 1 to, this is negative 1 to 3. So let's say this is 3. Okay. So we have change of function. Means that we have two functions we need to evaluate. So it's from negative 1 to 2. We use the first function, and then from 2 to 3 we need to use the second function. Okay, so by applying the properties of definite integral, it will be negative integration of 3x plus 4 respect to x from negative 1 to 2. We stop at 2 and then continue adding up by from 2 to 3 of a function, integration of a function 1 over 2x squared respect to x. So integrate separately because it's a different function. So integrate 3x plus 4, we get 3x squared over 2 plus 4x from negative 1 to 2. And then integrate 1 over 2x squared, we get 1 over 2x cubed over 3. So the bottom one can be 6 lah, from 2 to 3. And then just substitute the value lah. For this one, substitute 2 first. So 3 of 2 squared over 2 plus 4 of 2. And then minus with 3 of negative 1 squared over 2 plus 4 of negative 1. So this is together lah for the first function. And then the second function is substitute 3 cubed over 6 minus with substitute 2 cube over 6. So use your calculator. The final answer will be 59 over 3. I don't like putting the fraction in the calculator. If you like, then that doesn't matter. It doesn't matter. So if it's me, then I will calculate first. This is 4. 4 over 2 is 2. 2 multiplied by 3 is 6. 6 plus 8 is 14. Minus with this is negative 1 will be 1. 1 over 2. So 3 over 2 minus 4. 3 over 2 minus 4, so plus 4. And here it's 27 over 6 minus 8 over 6. So it will be hard to use calculator. So plus 27 over 6 minus 8 over 6. So it will be 27 minus 8 is 19. So I use this simplified value first before I put it in calculator. It's up to you lah. If you don't want to do any careless mistake, then we can directly substitute the value into the calculator and check one by one whether you put it correctly or not in your calculator. Okay, so this is our final answer, 59 over 3. So I think that's all for this lecture. For the topic 2. So we finished with integration. So what we learn in integration? We learn how to integrate by using the properties, the formula, the rules, and then we have the special formula, and then we have the technique, which is the substitution method, and lastly we have the definite integral where we substitute value of the limits. The value of limits. Okay, so that's all for topic 2. Try to continue with tutorial number 4. Okay, so that's all for topic 2. Thank you, class.